In Module 4, Lesson 3, we're going to continue to talk about fractions as division, and with this lesson, we are going to be looking at how that fits into story problems. The story problem we're going to be talking about today is, a baker poured 4 kilograms of oats equally into 3 bags. What is the weight of each bag of oats? First, we want to ask ourselves what the context of the story problem is. And we know that there's a baker and he is pouring oats, which is kind of like a cereal, into 3 bags. And so you kind of just highlight what you think constitutes as that context. And then we want to take a look at the quantities. And we will show quantities with red. And the quantities we have here are 4, and what that 4 means is kilograms. And then we want to take a look at the 3 and ask ourselves, what does that quantity mean? And it also means bags. Finally, we want to think about what operation we are going to use to solve this problem. And to do that, we look for those keywords, those action words that tell us how we are going to be sharing these 4 kilograms into 3 bags. And the word that we notice, the action word we notice immediately, is that word poured, where you're pouring something into. And if you think about poured, what you're actually doing is you are dividing. And so if you're not quite sure what that action word means, you want to think about other synonyms or words that are similar to that action and which operation that would fit into. And so we know now that the operation that we're going to be using is dividing. Next, we want to think about, in this chart, and start at the left side, and we want to think about how are we going to write a division expression for this problem. And the words division expression are just fancy talk for write an equation. One of the things that we want to consider is which one of our numbers comes first. How do we know that it comes first? In our whole group lesson, we talked about how our starting amount comes first, and our starting amount is going to be that 4 kilograms. So we would write our 4 first, and we talked about our operation is division. And then what we're dividing that 4 kilograms into would be our second number. So our division expression would be 4 divided by 3. Next, we want to move into drawing our visual of our equation. We want to start and think about, we have 4 kilograms, and I'm going to represent those kilograms with these boxes here. And we want to think about this, how many holes do we have? Because remember, in fractions, you always want to think about how many holes. And one of these squares we've identified as our hole. And then I just like to draw representations for those 3 bags that we are dividing them into. Now we ask ourselves, what do we do to solve this problem? Since we have to divide those kilograms into 3 bags, we can start by dividing each of those holes, each of those kilogram holes, into 3 separate sections, 1 for each bag. And then we can start partitioning them off into each bag. So we'll do, this bag will be our brown partition. 1 from each of those kilograms can go into that brown bag. And then we do the same for each of the other bags, except we'll use a different color. Now that we have shown how many are in each bag and we've divided them equally, we want to ask ourselves, what is the size of each part? And we have, in fractions, we know that our denominator is how many parts in each whole, and in each whole there are 3 parts. And one of those parts would be 1/3. And so we ask ourselves, in this brown bag, how many parts do we have? We have 1, 2, 3, 4 parts. But we also have to realize that those parts are out of a 3-part whole. So we have 3 1/3. So our answer would be 4 3/3, which would also be our improper fraction. And if you take a look at our conjecture up on our board, we said when we're dividing a number by another number, that first number will be in our numerator and that second number will be in our denominator. So our conjecture works for this problem. Another way to think about writing this division expression is in unit form, and how we do that is we take a look at how many parts and what those parts are labeled. So in all of our 4 wholes, there are 12 parts, and each of those parts is a third. So in our 4 wholes, we have 12 thirds, and we would still be dividing that 12 thirds by 3. So if you take a look here, because we've broken it down and we've decomposed that 4 into its parts, into thirds, we have 12 thirds divided by 3, which would equal 4 thirds. Because we took that 12 and we divided it by the 3 to get 4, and then we take our unit name and we drop that down to name our unit form. So 4 thirds, which is also how you would say this improper fraction, 4 thirds. So that is just another way to think about writing this division expression, breaking your wholes down into parts. Now that we've solved it using our previous conjecture, we're going to think of another way to solve this problem. And you want to ask yourself, can you think of another way to solve this problem visually? You can go back and you would draw your same 4 boxes because your wholes remain the same. Now we want to draw our bags, and we have our same 3 bags. We could take and use our wholes and divide each of those wholes into one bag, starting to distribute them or divide them evenly. So into the second middle bag, we would put another one, and then into our final bag down here, we would put in a third. But what you notice is that we are left with a whole another kilogram, and we have to ask ourselves, how can we continue to solve this problem? What can we do with this extra leftover kilogram? And knowing that we have to put it into these 3 bags, we can kind of use a strategy that we used previously, and we can divide that last kilogram into thirds, and we can continue to distribute each of these parts into the respective bags. And just like we did above, we want to make sure that we are naming our parts. And since we have 3 parts in our whole, and each of the sections is worth 1, that 1 part in each bag would be worth 1/3. So in the brown bag, I have the 1/3 and a 1 whole. And each of the other parts and bags would be distributed equally into each of the other bags. Then we ask ourselves, what is this number called? We know it includes a whole number, a whole, and we know that it includes a fraction, and we've talked about how that is called a mixed number when you have both a whole and a fraction. So another answer is 1 and 1/3 would be in each bag. And then we also want to remember that we always want to name our units, and these units we know that we are dividing kilograms into each of the bags, and that's represented by kg. So finally, we kind of ask ourselves, is 4 thirds and 1/3, are those equal? Did we come out with the same answer? They don't look the same, but does it represent the same value? And so if you need some further qualification of that outside of these visuals here, you can draw them out and see that they are, in fact, the same number. Next, finally, we are going to take all of what we did here into our standard algorithm and how we would use this idea, these visuals, and relate it back to that and understand how and why this standard algorithm works. So we set up our division sign here, and we would fill in our numbers, and we know that this first number here actually goes on the inside of our standard algorithm, and then the outside would be the second number. So here we have 4 divided by 3, because you kind of read those backwards. And we go through the process of solving this and asking ourselves, how many times does 3 go into 4? It goes in 1 time. And then we know that we multiply and then subtract. So 1 times 3 is 3, and then we subtract it down here. And we have 4 minus 3 is 1. And I know that in the past we've taken this to the decimal, but right now we're going to stop and we're going to actually continue to think about this as a remainder. So we have 1 remainder, and I want you to think about how can we change this remainder into a fraction. Another way to think about this is how can we keep sharing our remainder? And we know that we have a remainder of 1, which, since it's a whole number, represents 1 whole. And we want to share it into those 3 parts. So we similarly, like we do over here in this visual, we break it into 3 parts. And we know that each of those parts is 1/3. So we would have 1 and 1/3. You can also think of this in a more numerical way, and you have your 1 whole here, and you can think about it as 3 parts in my whole, and you would have 1 out of 3 parts here. Now we want to think about how can we check our answer to make sure that we solved it correctly, because it's always good to go back and check and make sure. We've talked about how, because we're doing 4 divided by 3, the inverse of division is multiplication, and you would multiply your answer, 1 and 1/3, by how many groups you have, which is 3. And it should equal that inside number 4. So 1 and 1/3 times 3 is how we would check our answer. What we can do is, because in this case we have a repeated 1 and 1/3 3 times, we can rewrite it as an addition sentence. So if rewritten as 1 is 1/3 plus 1 and 1/3 plus 1 and 1/3. So I would add my wholes, 1, 2, 3, and my fractions all have the same denominator, so I don't need to make equivalent fractions, but I also know that my denominator, my whole, stays the same, 3, and then I would add the parts, 1, 2, 3, and I have 3 over 3, which also can be rewritten as 1 whole. And so I would add that to my 3. So I'd have 3 wholes plus another whole made up of fractions, which would equal 4. And that is exactly the number that I was looking for. So my answer is correct.